This is the part that I'm going to be making today. It's based on a design I found on a YouTube channel called Need It Make It. His design wasn't quite what I wanted. It was pretty darn close, but I wanted to make some changes here that I will explain further in the video. But the quick version is I wanted to have the magnets be easy to get size. So these are 10 millimeters by 10 millimeters. I felt I didn't need as many magnets as he had. I think he had 6 and I only have 4. And then the last thing is I wanted to have the magnets come in for the back. And there's a thin skin over here that keeps them from coming out. You can see it's larger in diameter there than it is there. That allows me to push the magnets out if I get them in the wrong polarity, but it makes it also easy to push them in. So we'll head to the computer and I'll show you how I went about learning from his design and then creating this version of the design. This is a design that I found by watching a video, and I liked the idea, but I didn't fully like the design. One of the things he did is had the magnets come in from the face side, and then he had to glue them in place. Originally he had them entrapped, but I decided I wanted to use a different approach where I have the magnets coming in from the back with a very thin layer, basically one layer, holding it in place. And by having it come in from the back, it's never going to pull out from the front. So I thought that would be a little bit more secure. I also found some magnets online that were 10 by 10, so a slightly different size. And I decided rather than modifying this, I would see what was involved in just starting from scratch and creating my own version. Before creating my own part, I wanted to see how he designed it, because it's easier to figure out what someone else has done and then do something more the way you would want than doing something from scratch. So if I scroll back here, he starts with the cylinder and then this spiral. And I'm not sure why he started with the cylinder first and then add an extension on both sides. This is where he adds a chamfer? No, what did he do there? Let me back up. Oh, he's combining the parts. And then adds a chamfer here to make it easier to 3D print. You can watch this video and he goes through this process. I'm going to show you the approach that I took to this. So I'll start a new file. And I'll start with the spiral. But the first thing I usually do is I do two things. One is I'll save the file. With a very imaginative name. And then I'm going to create a component. I always like to create a component. It's a good practice because I never know if I'm going to come in and create another component. And there are operations that work well with components, etc. So I almost always try to start with a component. Now I can add the spiral, making sure that this is the active component, or a coil, and I'll just put it here. And I'm going to want it to be 4 inches probably. I'm going to keep this in millimeters, so it'll convert it to inches. And then what I want to do is set up some parameters to drive all of this. So I'll go and start creating some of the parameters. I kind of create the parameters as I go along. The first one that I want is going to be the pipe inside diameter, because this is going to screw inside the pipe. And I could keep it in millimeters, but I'm going to change this one to inches, so I can just type in 4 inches. Next, I want to have the thread pitch. And yeah, I wrote down some of these numbers from the other design before I got started. So I'm just entering those values I already got from his design. Now the thread width that I just added here is going to be the diameter of the thread. And then finally, something that does not have a unit, which is the number of turns that I want. So I'm going to use 3 turns. So now I'll go back and modify this to use those values. So the first value is the pipe inside diameter, and then thread turns. I want to change this so it's revolution and pitch, so it will use the pitch. And I'm not quite sure what happened there. It did not like that. Unfortunately, I can't save this. So let me go back to something here. Nope, it doesn't like that either. So I'm going to go back and see if I got something wrong with the parameters. Thread turns 3. Okay, I'm not quite sure what happened, so I'll give this another try. And something that I do when I run into problems like this is I'll go in and make a small number of changes at a time. So first I'll start with changing this value, the diameter. That's fine, so I'll go ahead and save it. And the reason I save it is so that if I have an issue, I can go back and just change the things that caused it to be red and caused this button to not be enabled anymore. So now I'll try the thread turns. Okay, that's all fine. And so the thread pitch. Oh, I think I know what's going on. So I think I need to set this first, which is the thread width. And now I can set the thread pitch. Yep, that's what the problem was. The other thing is I want to change the direction of this so it becomes a left-hand thread. Now this coil represents the outside of the thread. I'm going to now create the inside of the pipe. So I'll say new sketch, and I'm going to add it to the bottom here. And then create a circle that has the diameter, the same diameter pipe ID. Okay, I can then extrude this. I'm going to extrude it with 2 directions. And for the top side, I want to go a distance that is based on an equation. So for the distance to go up, I want it to be the thread pitch times the number of thread turns plus the thread width. And you'll see why that makes sense in just a second. So thread pitch times thread turns plus thread width. And if you look, you can see that goes above, and this is giving us a little bit of extra distance for the chamfer we're going to add later. Now, I do want to make this join as well so that it connects with the threads and becomes one body. For the other direction, the distance that I want to go is just the flange to, oh, I need to create a new parameter for that. So this is going to be something that I call flange to thread, which is kind of the spacing between the last thread and the flange that we're going to use the bottom that has the magnets that hold the different parts together. So I'm going to want that one to be, let's see, what did I set it to? Okay, so I'm going to add a variable, several variables. The first thing I want to add is something called the flange height. Actually, I'm going to go back further. So the flange height is going to be based on the magnets. So I want to set up the definition of the magnets. So I have a magnet height, which is going to be 10 millimeters. And then I have a magnet diameter, which is also 10 millimeters for the magnets I bought. Now that I have those, I can define the flange height. I'm going to make that the magnet height plus 1 millimeter. And I make it at 1 millimeter taller just so that the magnets are slightly below the surface on the back. I also need to have something that I'm calling flange to threads. So that's going to give me an idea of how much space that I have between the last thread and the flange. And that's also defined as an equation. So it's flange height plus thread width plus 10 millimeters. Okay, so now I can go back here and use that second parameter that I just defined. And that gives me the extension down below. The next thing I want to do is add a chamfer, and the chamfer is something that will make it easier to 3D print. I'll go ahead and say chamfer, and then I'm going to want to select the top circle as well as the bottom circle. And for the width, I'm again going to use an equation. In this case, it's going to be 0.4, in other words, 40% of the thread width. 0.4 times thread width. And you can see this is giving a nice slope that will make it much easier to 3D print. Now the next thing that he did, and the reason I keep saying he is because this is from the Need It Make It channel on YouTube, and I don't know his name. So if someone can put his name in the comments below, I'd appreciate that. He basically has, instead of these sharp transitions at the beginning and the end of the thread, he cuts it off so that it's a better transition. So what I'm going to do is add a sketch here, and I can use that as the sketch plane. Then what I want to do is to project, and I just typed P for that. And I'm also going to turn this on to construction. So I want to, rather than that, I'll just select this. And then I'm going to rotate here around to the other side. Press escape to stop the rotation and select that. Now at this point, I have both of them selected. But just in case, I usually like to push these out a little bit more. So I'll say offset. I want to go in the other direction, and then I'll do the same thing for down here. Oops, I have to do that as a separate operation. Okay, so I'll go back here, say OK, and then go back down here and do offset again. Flip. Okay, now I want to draw a vertical line, and I'm just going to draw it from there to there. The purpose of this line is so that this is the area that I'm going to extrude. So I'll add a line down here as well. I'm using my space mouse to move it a little bit easier. Line, make sure it's vertical, and then do coincident, finish sketch. And now I can extrude. These are going to go in two different directions. So I want to select symmetric, and then I'm just going to drag. And in this case, I do want to cut. And now you can see it has a nice lead in and lead out for the thread. The next thing I want to do is shell this out so that there's an opening here for the air. So I need another parameter. And I'm going to call this wall thickness. And then set it to 2 millimeters, which should be a nice strong thickness and not too thick. Then I'll go ahead and shell this out, and I want to select both the top and the bottom, so I'll Control-click to select both of them, and then change the inside thickness to that variable or parameter I just created. And there we have it, it's nicely shelled out. The next thing that I want to do is I want to add the flange along the bottom that will house the magnets. So I'll go ahead and create a sketch along this surface here. Now it's a little bit tricky for me to tell what I want to select as the starting point, so sometimes I have to rotate this at an angle. Then I'll do project, I just type P, and I want to select this right here as the circle because I want to make the flange move out from that point there. So I'll go back to looking at the bottom, And then I want to add another circle, like so, and I will make the difference between them, which I'll do by D for dimension, to be 4 millimeters. I'm going to want to add the magnet up here, and I'm going to repeat this around in a circular pattern after I create it. So I'll start by creating 2 concentric circles. The inner one represents the hole for the magnet, and the outer one represents basically the wall thickness that retains the magnet in place. I want both of these to be vertical to the center point. And then the other thing I want to do is to make it so that this outer circle, which is just extra material, is tangent to this inner circle here. So I already have the diameter, which is the magnet diameter, but there's another parameter that I want as well. So I want to add a parameter called hole expansion, which allows me to adjust the diameter of the hole a little bit to compensate for 3D printing imperfections so that the fit is not too tight. Now that I have it, I can define the diameter of this as magnet diameter plus the hole expansion. And then I want this to be 5 millimeters. To make this a little bit nicer, I want to add a little fillet. So I'll go ahead and use a 3-point arc. I've tried using tangent arc before, but I often have problems, as you can see here. This won't let me select anything. So I'll change it to just 3-point arc between these two here, like so, and it already picked up one of the tangents. And now I'll just add the other tangent. I'm going to set the diameter of that just arbitrarily. Not sure why it's doing that. Anyway, I want the diameter to be magnet diameter, like so. And there we go. That's interesting. I wanted to have this call out a little bit farther out, but it's not letting me do that, so that's okay. Now go ahead and do the same thing on the other side. I could just mirror it, but it's just as easy to go ahead and create it on the other side, like so, and then make these so that they're equal, like so. Whoops, I forgot to make this tangent to this over here. And now I have the geometry that I want. So I'll finish the sketch and then turn this around and I'll extrude this. And I want to select all the parts that I want to extrude, like so. And then I want the height to be minus flange height. So that gives me one of the openings for the magnet. The other thing I want to do is I want to trap the magnet in here. So I'll add another sketch. First I'll project this, and then I'll add an inner circle. And for that, I'm going to just arbitrarily make it the magnet diameter divided by 2. Then I'm going to extrude this just a small amount. So I'm going to extrude it minus 0.2 millimeter, which is a little bit more than the typical layer height. So you can see there is just a small amount of material there, but that's enough to hold the magnet in place so it won't come out as you use it. But with the right fit, this will be a nice push fit. Now I decided to see if I could get by with just 4 magnets. So what I want to do is do a circular pattern. And I want to pattern features. So the features I want to pattern are this feature and that feature. Then for the axis of rotation, I want to select that axis, and then I'll make this so it's 4. And there we have it. This is the basic flange. I could stop here, but he also had something to hang the bracket, so I decided I'll put a boss on one of these edges to hang the bracket. The next thing I want to do is to add a boss to one of the sides here that I can use to hang this if I want to have one of the connections hanging in a certain place. I don't know if I will really need that, but I'm going to add it anyway. Now, if I show the origin, you'll notice that the 2 planes that I have are in line with the magnets, whereas I want the boss to be 45 degrees from that. So what I want to do, I'll hide the origin, is create a plane at an angle of 45 degrees. Then what I can do is add a sketch to that. And I want to pick up a line that I can't see at the moment. So I'm going to rotate this, press Escape, press P to project. And this is the line I want to pick up there. And I actually want to pick up, that's good enough. So I'll pick up that line. And one of the problems is I want to rotate this back so it's straight on. And I could use the look at, but then I'd have to show the construction plane that I created. An easier way is to just finish this sketch and then start it again, and that will automatically rotate it. Now I also want to pick up this edge here so that I can draw a rectangle from here to there. And I'm going to have this in a little bit, just so that I don't extrude something inside the middle. But I do want this to be coincident, and then I also want to add a line, which I'm going to make a construction line from there to there. And that will allow me to have the dimensions be from there to there. So the next thing I want to do is I want to add an oval hole. So I'll use a slot, and I'll use an overall slot, like so. I want to turn off construction. And then I'm going to set up some dimensions. So I'm going to have this first dimension be from there to there, and so I'm going to set that to 4 millimeters. So I have a nice wall thickness. I'm going to set this distance to 2 millimeters. And then I'm going to make this overall length 6 millimeters. And then finally, I want to set the width here to be 4 millimeters. I'll put it there. Now this isn't fully constrained yet, so let's see why not. It's not centered. Okay, so what I want to do is add another line. I'll make it a construction line. I'll put it there and there. And you'll see it's at a slight angle, so if I make that vertical, now this has constrained this further. It's still not fully constrained, so what's missing? Okay, it looks like it's fully constrained. So I'm not sure why it's complaining. So let's try a new feature and see if it'll tell us what's missing. Okay, this is the AI generated constraints, and it's taken a little while. I see. I don't know why I need that constraint. Got it. That's the constraint. Okay, that was missing. So I'll just make this 3 millimeters. That should be plenty. Finish the sketch. Whoops, it's still not constrained. Okay, I can't see what's not constrained about it because I can't move anything. Even with this, I can't move anything. So I'll just ignore it. Again, I don't know why it's not constrained, but I can do the extrusion now. Okay, so let me rotate this so I can see what I'm doing. So I'm going to make this symmetric and set the total distance to 8 millimeters and make it so it's join. Yep, that looks good. And then I'm going to set some chamfers to make it look a little bit nicer. So I'll go here and here and set that to 1.5 millimeters. That looks good. And then I'm going to set a chamfer along the bottom. Actually, I set a fillet, I should have said. And along the bottom, I'm going to set it to 0.4. This is something I generally do so that I don't get elephant feet. It just makes it a little bit smoother when it prints. But with the bamboo, it's less of an issue because the bamboo does such a great job. And then I'm going to add another chamfer across the top of 1 millimeter. And it's ready to print. These are the magnets that I'm using. And I already have two versions of it, one with magnets in it, and the other I've just printed that does not have the magnets. And what I want to do is I want to have them so that when they're connected via the magnets, they line up like so. And so what that means is I need to make sure that I have the correct polarity to go in there. So that is the correct polarity. So what I'll do now is I will push that in like so, and then I'll carefully grab this, flip it over, go to the next one, push that one in, flip it over again, push that one in, and this is to make sure that I have alternating polarities on the magnets, so that when I connect them, like so, they connect correctly. And you can see they are held quite firmly together. I can pull them apart. And one of the magnets went flying. It seems like one of the holes is not quite small enough. So I'll probably put something in there like a little piece of scrap of paper to give it some friction so that it stays in place. So give me a second, I'll find the magnet and be right back. Okay, I got a tiny scrap of paper, and so it's this magnet right there. So I want to make sure I have the correct polarity. That is the correct polarity. So what I'll do is I'll take this piece of paper, like so, and then when I put it in the hole like that, well, I didn't get the paper in there correctly, but now it doesn't come out. So that's a quick way to deal with that. So now, again, they're held nice and firmly in place. It's easiest to slide it than it is to pull them apart, but you can pull them apart. But that's plenty of holding force, so I'm quite happy with the results. So the reason that I made this is because I want to invent the fumes that come out of each of my injection molding machines. And I have multiple injection molding machines, so what I really want to do is I want to design something like this, where this will mount to each of the injection molding machines on one side and provide fairly good suction of the fumes to get them out of the room, and then I can just move the hose that's attached to the fan to the different units, and then I'm done. And then this part right here, I tried two different designs. I think this was the first one, and this is what I settled on for being able to hang this. I'll see how this goes, and I may change the design as I get some experience using this.